Hello, welcome back. So the last part of this lecture is the SPARQL protocol. Before we actually go into the protocol, I'll talk about another detail of RDF that so far I skipped over. You might have seen it online or in some of the examples, but I haven't talked about it, which is named graphs. And then I'll go into the practical side of serving knowledge graphs, and that's something we'll cover more in the labs as well. But let's start with named graphs. So this is not really about querying. This is just another feature of RDF that I haven't mentioned in the beginning, since I didn't want to introduce too many things at once. But now you are used to RDF and RDF data. So there's one more detail, namely that RDF data can belong to a named graph. So imagine you have data from multiple sources and you want to store them together. Then instead of mixing all the triples in one big graph, you can separate them into multiple named graphs. Now it's a bit like having on one server multiple databases with different names. So the RDF data can either belong to a named graph or it can belong to a default graph, which is unnamed. And basically so far, we just left everything in the default graph, which is the unnamed graph. But you're not limited to that. You can give a graph a name. Oops, sorry for that. So then the question is, how do you show this in a data file in a serialization format? And there are two more formats that, again, you might have seen, but now you officially learn about them. One is called trig and one is called nquads. Trig is an extension of Turtle for named graphs, and nquads, as you can guess, an extension of n triples for named graphs. How does this look like? So trig looks very similar to Turtle. There is a new thing here, which is the graph statement. And you can see that we have two named graphs, a named graph about Bob, a named graph about this picture. Yeah, this is the Mona Lisa again, and a default graph. And we have different information, a number of different triples in each of these three graphs. So the triples here belong to the first named graph, the triples here to the second named graph, and the triples down here belong to the default graph. And if you look into this RDF primer, again, I highly recommend you read it because this is a really great, quick introduction to RDF, well written, a good overview. Then you've seen this example here. So this is our example from before, except now we are splitting it into these three different graphs. The first graph holds all the data about Bob. So this is something you might have in a social network. Now, Facebook might keep knowledge about Bob, what Bob is interested in, what Bob liked, and who Bob knows in its internal knowledge graph. And we'll come to the Facebook graph in specifically in the next lecture. Then we have a graph about this picture, the Mona Lisa, and this might be stored in a different graph. A museum graph that has information about all the exhibitions, the paintings, the artists, and so on. And then we have a third graph that talks about licensing. What is this published by and under what license is it available? And well, this is the graphical representation of what we've seen here. So we have split the same triples that we had before, but we split them into these three different graphs, two named graphs, the Bob graph, the graph about the painting, and a default unnamed graph. How does it look like in n quads format? Well, you know, n triples is just three triples on a line, and n quads is four triples on a line. So the four URIs on a line. So the fourth URI is the graph IRI. So this is the URI of the graph the triple belongs to. So the first triple belongs to this graph, the second triple belongs to this graph, and the third one doesn't have a fourth element, so it belongs to the default graph. So why do I mention this now? this is important for SPARQL queries because they can query multiple graphs. So far, we always queried the default graph. So we didn't give an explicit statement about which graph we want to query. So everything was done against the default graph, but it's possible to query multiple graphs. And this is done with the graph statement in here. So you would have, if you have named graphs, you can have a query that specifically have triple patterns against these named graphs. Okay, so much about named graphs. Let's now look into how you can serve graphs, serve RDF data over a network. So I mentioned many times, this is a web standard, this is web technology. So this is obviously built on the same infrastructure as the World Wide Web. You have HTTP requests, and the very simplest way to get RDF data from a server is just to request an RDF file using a simple GET. You as the client can say, please give me a turtle file or an n triples file. And then assuming this file exists, the server will say, okay, here is your RDF data. So this is possible. And in some cases, this is something you actually do. But in many cases, this wouldn't really be practical. If you think of really big data sets like DBpedia, you couldn't just say, now I want to have DBpedia and possibly some other big graphs and query them on your laptop or on your mobile. You would have gigabytes of data that you get back, and then you would have to store all the triples to do something with them. So this is not really a scalable approach, or this is nothing you would do for most applications. Instead, what do you do? Well, what we just talked about the whole lecture, you would run a query. So the first part was the query language, select, construct, ask, and so on. And the other part of SPARQL is the protocol. So this defines how to send a SPARQL query using an HTTP request. And essentially how it works is that when you have a SPARQL server, it has an endpoint that connects over the web, that has a certain port that you can connect to, and then you can send an HTTP request to it. And the HTTP request is given here, and it includes the query itself. So this has to be an encoded query string, meaning you do an URL encoding where you replace special characters like spaces and so on. And there are libraries for that. So if you haven't seen it before, look up query encoding. It's not something special to SPARQL. It's something for general web encodings. So you send the SPARQL query to this endpoint, and then you can have some additional information, in particular if the query is for the default graph or a specific named graph. And like always, you can have this as a GET or a POST request. GET request for retrieving information from the graph. And if you want to have something that modifies graphs, you have to do a POST request. What you also can do is combine multiple endpoints. So this is different from querying named graphs. Don't get these two confused here. With named graphs, we are querying one endpoint with a knowledge graph, which has multiple named graphs inside. But now let's say you want to query multiple knowledge graphs that are on different servers. And this is something that's also possible since SPARQL 1.1, and that's called a federated query. So you can retrieve information where the first couple of triples come from one graph, let's say the Concordia graph, if it had one, or your own graph that you're using, and then you combine it with information on a different knowledge graph server, for example, DBpedia or Wikidata. So the query will run against different endpoints, and then you can combine the results from these different endpoints in one complex query. So how do you set this up in a practical application? what you need is a server, just like a relational database server. Here you need a SPARQL server. And like always, you have a choice between commercial software, open source software, and a cloud-based service. So instead of giving you a long list of all kinds of products, I'm just giving you 3 examples that are 3 typical examples. A commercial software that you'll see very often is the one by Virtuoso, the open link server, because it has both an open source edition with a limited feature set and a commercial edition. So if you go to GitHub, you can see the open source version, and you can look online what the difference is between the open edition, the open source edition, and the full commercial edition. As always, lots of applications nowadays are run on the cloud, for example, on the Amazon Web Services, and all the cloud providers also have a graph database with a SPARQL service. I'll have a link to this in a second. And then finally, what we'll use in the lab exercises and what you'll use for the project is an open source version, which is an Apache project, Apache Jenna. So again, I'll show this in a second. But before we go there, you can have a look at this quick introduction to the AWS service. So this is just a 2-minute video, basically a commercial about this graph service on the AWS. So just to give you an impression how this would look like on a commercial cloud software deployment, which you obviously have to pay for, like everything running on AWS. So I'll give you 2 minutes to look at this, and then we'll come back to the last part of the lecture. See you then.